In this video, I will explain Lab 3 or linear regression on iris dataset. For the Lab 3 linear regression on iris dataset, first is import non-PSNP. It's a forced numerical computing with arrays, matrices, and map functions. For the second is import pandas as PD. It simplifies data manipulation and analysis with data frame and series. For the seaborn as MSS, that simplifies creating visually appealing statistical plots based on matplot. Then for the matplot.pyplot as PLT, or enables creating static, animated, and interactive visualizations in Python. Last, for the warnings. This warnings module controls and manages warning message in Python. Then for this code, it tweaks the look and size of seaborn plots, silences any warnings, and ensures pandas shows up to 999 columns when displaying data frames. Then for the third cell box, or this line reads the irs_.csv file and stores its contents in a data frame called data for easy analysis. Then for this code, this line shows the first 5 rows of the data or data frame, giving you a quick glance at the dataset contents. Then here is the output. Then for the data.info, or this gives an overview of the data frame, showing details like column types, missing values, and memory usage. And here is the output. Then for the data.describe, this gives a summary of the numerical columns in the data frame, showing case stats like the mean, minimum, and maximum, and percentiles. Then for the data species value_counts, or this tells how many times each species occurs in the species column of the data or data frame, like this. Then for the rows, call equals data.shape, or this tells how many rows and columns are in the data or data frame, and prints that information about this. Then for the SNS, equals data.drop, or first it drops the necessary ID column, then creates a per plot where different species are color coded. The top half of the plot shows scatter plots to highlight patterns. Then the bottom half uses like smooth KDE plot to show data density, like this. Then for this code, each flash shows how the data is spread for a specific feature, like sepal, petal length, and petal width. Then lines inside represent individual data points, making it easy to see how values cluster. Or the autumn color palette gives it a warm, visually appealing look, like this. Then for this code, for the mapping, it prepares data for machine learning through mapping species names to numbers, like Iris setosa, Iris versicolor, and Iris virginica. Then it dropping unnecessary columns like ID species, ID, and species, and converting the data into a non-free array. Then For this code, it is reshaping the target variable to match model requirement. Then last, with adding a bias column or a column of ones. So X for models like logistic regression. Then for this code, reinitializing model parameters or theta, then setting a random seed for reproducibility, then generating a 1/5 matrix of random values for initial weights. Lastly is printing theta to check the assigned values. Then for this code, it trains a model using gradient descent by initializing the data randomly and setting learning parameters. Second, running gradient descent to minimize error over 1000 iteration. Then it make a prediction using the optimized data. Then last, it plotting the cost function to visualize learning progress. And here's the output. Then for this code, it plots the cost function with J over iteration to visualize how the model learns. For example, in x-axis, it is a number of iterations. Then for the y-axis, it is a cost or error. Then there is a goal, or a decreasing trend shows the model improving, like this. Then for this code, we are visualizing model accuracy by comparing actual versus predicted in iris species. For example, this VLT.x level or dataset size, color, glass green, VLT, .y level or iris power, or color green and VLT type iris power, resolution iris basic color 2, iris Virginica plus 3. Then the goal of this is points should align with the red line for accurate predictions, like this. There's the output. Then for the last cell box, for this code, we are calculating model accuracy by checking how many prediction match the actual levels. And it contains a formula or correct predictions. Total equals 100. Then for the fix, use np.min. Then prediction. And thank you for watching. Take care.